Okay, so welcome again to this brief review. I will try again to keep it short so as not to have many spoilers for tomorrow's presentation. So how OpenSlice started, or what OpenSlice is essentially. So it is an open source operation support system that aims to stand at the OSS part of the HCNV architecture, as you can see in this picture at the top left. It offers network as a service, or you can design network as a service solutions following standards from ETSI, TM Forum, and 3GPP. And it's, at its northbound, it exposes TM Forum APIs, so it can interact with and be interoperable with other solutions in the industry. And at its southbound, it can interconnect with NV orchestrators with using HCNV APIs, namely SOL 005, for those who are familiar with. And also it can integrate directly with Kubernetes through its native API to deploy services. Also, work that is done during this period of OpenSlice is that we translated GSMA generic slice template towards TM Forum model, service specification model. You will see more information about this as this session proceeds. So what is network as a service, essentially? As you can see, the network from the far edge to public cloud comprises of many devices, services, transport links, etc. The majority of them, or all of them, essentially, provide controllers. And these controllers should be exposable towards the northbound with standardized APIs, so to promote interoperability, as services or categorized in specific categories and catalogs. These services are exposed to external stakeholders or third-party services that can order services through a UI or directly through this standardized API. And when this happens, the end-to-end orchestrator aims to consume the exposed APIs of the controllers and orchestrate an end-to-end service employing all of them that is later exposed towards the customer, even if the customer is an external stakeholder or an external application. So OpenSlice stands at this box. So what we have done is to provide a UI and the respective standardized API so as to interact with external stakeholders. It comprises also the end-to-end service orchestrator that will facilitate the capture order, and we develop southbound consumers of infrastructure that will enable us to provide end-to-end service. So a glimpse at OpenSlice architecture. This is a service-based architecture, as you can see. It comprises of the TM API families and the respective portal for each layer of TMF, let's say, model, which is a resource, service, product, etc. It comprises also a proprietary API to manage NFV artifacts, VNFs and NSDs. And all of these, of course, are connected and through the service bus. Of course, OpenSlice comprises an authorization service, bug reporting service as well, a central logging. It comprises the Mano client API, which is the client that enables communication with underlying NFVOs based on HCNV model. It comprises Metrico component, which is something that is currently under development and will be delivered by the end of this release cycle, which is a component that provides metrics or monitoring data from external sources and binds them towards the services that are running so as to create closed loops. It provides an API towards Kubernetes, a controller towards Kubernetes, and of course the OpenSlice service orchestrator, which is in charge of orchestrating and providing the overall service. So starting from, let's say, the origins of OpenSlice, which was originally to provide NFV support. So what OpenSlice allowed or used was a portal and APIs to allow service providers and customers to design and browse any available services offered. NFV developers, especially centered at the NFV world, that can provide and onboard NFV artifacts, VNFs and NSDs, that you're already familiar with OSMOS probably, and also third-party applications that they have direct access towards the API. So there are two portals for this reason. The services portal that is oriented around the service providers, and the NFV portal, which is oriented around the NFV developers. And of course, as we've said, there is third-party access via TM Forum APIs that third-party services can leverage to communicate directly with OpenSlice. When it comes to cloud-native support, which is a recent addition to OpenSlice since the last release, and of course this will be an ongoing activity, OpenSlice supports cloud nativeness both in terms of its own installation, as you can see here, which is achieved both by Docker Compose and Helm chart, but also in terms of executing and deploying services. So on that sense, OpenSlice aims to capitalize on the extensive Kubernetes ecosystem that many developers are familiar with, and especially the essence of custom resources. So what it tries to do is to wrap around TMF APIs using TMF Kubernetes APIs, using TMF APIs and models. So with this reasoning, it provides loose coupling and enables developers to reproduce the already known knowledge of Kubernetes and Helm charts to orchestrate, to provide more orchestrational scenarios. Also, of course, as it goes without saying, it enables the usage of the broad ecosystem of Kubernetes. And also it can expose CRDs as service specifications to include them in several complex orchestrational conditions and provide interactions or, let's say, complex services with other systems as well, with run controllers, other Kubernetes clusters, or even NVOs themselves. So to have a more illustrative approach of this we would aim to have a Kubernetes cluster. The developer would program any controller that executes any logic at any language of its preference. And this controller will be mapped as Kubernetes CRD, custom resource definition. So the service that resides in OpenSlice will translate this CRD towards a resource specification definition from TMF, which can also be included in a service specification. Just note, the service specification, of course, can comprise of many resource specifications. We'll see more of this later. So the third-party stakeholder can use the UI or the API to order the design service specification, and the orchestrator will provide the signal towards the Kubernetes to instantiate the custom resource definition towards a custom resource with the respective, let's say, underlying resources, secrets, services, config maps, the resources that you know from Kubernetes. These resources will be referenced back towards the OpenSlice portal and will be mapped as TMF models, and will be exposed towards the service, towards the customer or the one that issued the order through the service catalog API. Of course, this will also enable a multi-cluster support, because the component that is essentially used for this translation and this deployment is called CRIDS, which is a CRD to TMF bridge, actually. And you can employ multiple instances of CRIDS so as to monitor multiple clusters that provide connectivity with OpenSlice through its central service bus. So this is the, let's say, this is the way to control many Kubernetes clusters or heavy deployments across a wide ecosystem of Kubernetes clusters. Some example UIs of OpenSlice that we will see also later comprises of different, let's say, models from TMF. So there is a dedicated UI for services, resources, products, and of course the NFV related UI, which is of course outside the ecosystem of TMF, but it is within the interest of Etsy. So we spoke a bit about the service specifications or the specifications in general in the previous slide. So what are the service specifications? Let's try to observe them as blueprints on which the orchestrator relies upon to provide the service. So in TMF world, the service specifications can comprise of a bundle of service specifications, and eventually all the service specifications will have to map with a resource-facing service specification, which is the actual implementing blueprint of the service bundle. In the Kubernetes model, let's say, version, the resource-facing service references specific resource specification that we will also see in the hands-on session that references directly a Kubernetes CRD to be deployed. So this hierarchy of the service specification, so we can have a parent and end-to-end service specification that comprises of many other children, let's name it, service specification, translates to actual instantiation of this hierarchy, and you can see that we have an end-to-end running service, which comprises of underlying supporting service, which eventually will map to direct Kubernetes resources, as you can see here. The same concept is followed at the NAV model, with the only difference that now the resource-facing service specification references network service descriptors in OpenSlice, which are synchronized by underlying and registered NFVOs. Other than that, the picture is the same. The only difference, of course, is that the underlying resources, now it's not Kubernetes, they are NAV resources that maybe you are familiar with, which is running network services and VNFs. Of course, a service specification can comprise and combine both of these models to the same service if needed. So how we come from service specification towards actual instantiations of services? This happens through service orchestration, which provides actually the recipe on how to provide services from service specifications. The actual instantiated service follows the life cycle of 3GPP, as you can see, which is preparation, commissioning, operation, and decommissioning. All this modeling from 3GPP was adopted by OpenSlice and was mapped to TMF model service state. Examples of this will be shown later in the hands-on session as well. So the respective component that actually is in charge of orchestration is OpenSlice Service Orchestration and Order Management, also in short, which follows also a model from TMF, namely 641, which is the service order. Also, the service order has specific life cycle states that we will also see later on this hands-on session. OSM relies on a flowable business process engine to provide the orchestration diagrams. And as you can see, this diagram, these BPMN diagrams, provide some initial context of how the orchestration will happen. So these BPMN diagrams are inside OpenSlice, and they are consumed when several orchestrational processes are being assessed. As you've seen, or you can imagine, these diagrams provide static orchestration. So they actually cover some scenarios, orchestrational scenarios that are the typical orchestrational scenarios of OpenSlice. But what comes when the user wants to provide something dynamically? So this is how we can say that OpenSlice also provides dynamic service orchestration when the user can inject specific code within the BPMN, already defined BPMN diagram. So for this, we have created the lifecycle management rules, as we call them, which, as you can see, injecting codes or specific landmarks within the lifecycle of a network service as 3GPP provides it. So it would be before we provision a service, while we create a service, after a service is activated, as the service is running with supervision, and after the service is being, let's say, deactivated. The lifecycle management rule tries to follow the no-code example, so the developer is not required to write any code, and only needs to use, let's say, a representational definition language, which is Blockly by Google, to provide some block of codes or some logic that is translatable in real time and injecting into orchestrational graphs. Some brief, let's say, introduction of which TM Forum APIs that OpenSlice support. Of course, we won't go one by one, because we will have also the opportunity to see some of them in action today. This is the last, let's say, part of the introduction of OpenSlice, which is something that I own you from the first slide, which is the GSMA to TM Forum translation. As you may be aware of it, GSMA provided this generic slice template, which is a template, a free text template, that tried to leverage the gap between the service providers or the vendors with the service customers. So to define specific 5G services, GSMA introduced some specific properties so as to try to map every 5G-oriented service that the customer would like to have. If I'm not mistaken, this template has around 50 properties that try to capture this holistically. Also, GSMA, at the same document, proposed some network slice templates that would describe some standardized slice templates or slices as EMBB mapped towards these properties, as you can see. So what we've done in OpenSlice is try to take every property of GST, which was in free text, and try to map it in the TMF service specification, so the designer can leverage and expose these properties towards the customer. So some brief usage examples of OpenSlice. Excuse me. So on the right, you can see some research programs that actually leverage OpenSlice, and it started back in the day with 5G in File, and also the history continues on with SNS and beyond, hopefully. And also on the right, on the left side, we can see the standard development organization that OpenSlice leverages, and also provide some feedback towards. So OpenSlice under ETSI. OpenSlice was the first standard development group that was introduced by ETSI, and it was kick-started in the previous October. So we just have a year and some more of life. And this is the membership and the participants of OpenSlice currently. As Sebastian saw, this is a straightforward process to onboard and become a member or participant in OpenSlice, so I will try to omit repeating that. And under the operation of ETSI SDG program, there was and there is a dedicated GitLab repository for OpenSlice, and also the project, the open source project from GitHub was migrated towards this GitLab project, and of course it's maintained only there. And of course, so as to be more industrial ready or prepare our releases in a more safe manner, we have introduced extensive CI/CD circles there, so as to build specific images and artifacts that OpenSlice comprises of. And also this repository hosts the images and the respective libraries that someone wants to, that someone needs to instantiate OpenSlice. Documentation, of course, is available for the main releases or the past releases, also for the development version. And under ETSI, we have been working under 2 releases. The first was released in July 2024, and currently we are working on 24 Q4 release to be released at January the next year. So coming towards the closing of this presentation, this is the vision of OpenSlice as it was for the first release, which was aimed towards cloud nativeness that you have seen in the last slides. The release that we are aiming to have now at January is aiming towards network as a service mainly, and aim to provide monitoring integration, as we have discussed. And with this, we can promote and, let's say, support SLA preservation and closed loops. I would like to provide ready-to-install services of OpenSlice, because currently, if you install OpenSlice, this is a blank project, this is empty. Someone cannot know what to do with it. So we try to template prototype services that someone can import and play out of the box. And we have also provided, aimed to provide an integration with Teraflow SDN under ETSI. And also, as a matter of fact, we have some demos and posters that you can see later at this conference. So this is achieved at this moment. And of course, we aim to also increase the security and testing through the CI/CD process of OpenSlice. Now, when it comes to the first release of 2025, we aim towards telco-native OpenSlice. And with that, we would like to have a conformance test against the TMF APIs that we used. As you have seen, this is a plethora of TMF forum APIs, but we would like also to have an official conformance stamp from TMF officials. We would like also to have integration proof of concept with OpenCAPIF, so as to close the circle with all the ETSI SDGs. And we aim also to provide a proof of concept with Camara. Some UI enhancements are expected, of course, and this will be, let's say, the transition towards AI, or at least I would call it towards intelligence, because we will aim to also incorporate some LLM prototypes in OpenSlice. And last but not least, the last release of the next year will aim towards the intelligent, the real intelligent OpenSlice. We'll incorporate more AI features, and also we'll have services based on user intent, both at northbound and southbound. Some more extensive information can be found here. So this also will be shared with you at the Hackfest page. So you will have access towards all this information. And that would be it regarding the brief introduction. Thank you.